Good evening, one and all. Today we discuss about the new concept, solid state physics. You know already solid state physics. We discuss about the lattice points, unit cells, Bravais lattices, Miller indices, interplanar spacing, and solid state using diffraction pattern, that is a crystal diffraction, X-ray diffraction, spectrometer, powder crystal method, and solid state physics importantly used in the electronic theory. So today we discuss about the new unit, that is the pre-electron theory, semiconductor and superconductivity. This is first session. The topic we have to say free electron theory. First of all, free electron theory, which is used in the case of semiconductor and junction, that is the PN junctions, and using the transistors and logic gates also. Now we have to discuss about free electron theory. Before we have to know what is the syllabus of the solid state physics in final year BSc. See the solid state physics. Free electron theory is defined in the case first the classical free electron model, which means how to obey the free electron theory, which condition which apply to the free electron theory, and it contains to prove the laws, conductivities and resistivities and some important materials. So how to produce using the free electron theory. So given the expression for the electrical conductivity and thermal conductivity, what is the electrical conductivity and thermal conductivity, and to find the expressions, to derive the expression for the both of the equations, and the scientist Weidmann French how to use the free electrons to find out the electrical conductivity and thermal conductivity of the both equations to take to getting the some important laws. So that laws is called Weidmann-French law. How to define and how to express and how the statement will be defined. Now we have discussed about next class. And the next one, failure of classical free electron theory. Some important works to fail to the free electron theory, because some electrons which works on charge carriers, holes, some materials. So some of the cases will be failure. Which cases will be failure we will discuss about in the case of free electron theory. That is the concept of solid state physics to use or to introduce the new cases of the free electron theory of the metals. And the second concept is semiconductor. Main important of the solid state physics to introduce semiconductor, because the semiconductor which both depends upon the electron theory. Semiconductor which is both conductors also and insulators also, and how to introduce the semiconductor, the types of semiconductor, and which contains the types of semiconductor which using the intrinsic semiconductor or extrinsic semiconductor, and the further types of the extrinsic semiconductor which we have to use on how to define the semiconductors. So we have to take the expression for the electrical conductivity of the free electron theory in case of the intrinsic semiconductor. What is the intrinsic semiconductor? To using the semiconductor material to find out the electrical conductivity, to use the semiconductor to find the expression for the electrical conductivity of the intrinsic semiconductor, and energy gaps to produce the experimental method, how to energy gap of the insulators, Fermi level and conductors, that is we have to define the energy band theory. So there are the three energy band theories there: conduction band, valence band and forbidden band, and how much difference of the conduction band and the forbidden band of the forbidden of the valence band. So how to determine this the energy gap, and the scientist will be defined, that is the whole of the scientist, how to take the semiconductor of the electrons and holes, which directions will flow through the electrons to find out the effect, that is known as Hall effect, and to take the coefficient and the applications of the Hall. So we have to say Hall effect, expression for Hall coefficient and applications of the Hall effect. That is the concept of the semiconductor. And the last one, the new concept, superconductivity. You don't know of the superconductivity. It is a newcomer of the solid state physics. What is superconductivity? Types of the superconductance. That is first type of superconductivity and second type of the conductivity. How to occurrence of the superconductivity, and how to destruction of the superconductivity with using the magnetic field, and applications of the superconductivity, that is a Meissner effect, isotopic effect, and some of the important applications of the superconductivity. And the last one, the problems will be solved of the free electron theory as well as semiconductor and superconductivity. This is the concept of the solid state physics on the basis of free electron theory of metals, semiconductor and superconductivity. So today we will discuss about, simply first we started the free electron theory. Topic is free electron theory. What is a free electron theory? How to define the free electrons? The semiconductor which contains the 4 valence electrons, do you know about the all? There is a 3 electrons will be left and 1 electrons will be going out, that is empty, that is known as hole. The hole will be created, that is known as free electrons. It is the upper bond or conduction band and valence band we have to create it. And how to define the electrons in the cases of outer shells of the metal atoms. So we have to see the diagram. First of all, the free electron positively signs, we have to indicate the electrons will be covered to the elements, and the positive sign of the electrons will be extra or donate the atoms. So it is the outermost shell of the metal atoms, so it is covered by the some electrons, that is known as the free electrons. We have to see the free electrons in the case of this diagram. So how to free electrons in the case of solid state physics? To study that, in solid state physics the free electrons model is a simple model for the behavior of valence electrons in a crystal structure of a metallic solid. We know that the valence electrons, which is a lowermost electrons, which is fulfilled of the electrons, and the electrons which flows through the conductions electrons with the help of forbidden energy gap, that is the way, that is the transfer of the electrons from the VB valence band to the conduction band. The main free electrons will be created, that is the valence bond. So we have to apply the solid state physics of the free electron model, the valence electrons of the crystal structure in the metallic solid. So free electron model which has to produce first is Drude. So we have to define Drude model. So what he says that the model which is application of kinetic theory and assumes that the microscopic behavior of electrons in a solid may be treated classically and looks much like a pinball machine with a sea of constantly jittering electrons bouncing and rebouncing of behavior relatively immobile ions. So what he said that Drude model, the electrons will be kinetic theory of the applications main important, because the kinetic theory which introduced the motions will be flowing through the easy, that is the kinetic theory will be says, because the electrons will be moving always. In the case of junction, the electrons which flows through the n type to the p type. And second one, in the case of microscopic behavior of electrons, because the microscopic and macroscopic we have two domains introduced in the case of the unit and measurements. So microscopic behavior means small electrons which are not see that. So we have to, when the current passes through the conductance, the electrons flows through the positive to the negative. So we have to say how to introduce, how to define, and how to signals will be present to getting the electrons will be flowing through, current will be flows through the circuit to introduce that. So such like a pinball machine, it means small pinball machine, the small current flows through the circuit. So we have to immobile positive ions will be created, that is known as the Drude model we have to define in the case of free electron model. But failure will be there in the cases of free electron theory, because it obeys the laws, some laws will be obeys, but which failure will be there. So how to failure in the case of Drude model, which is not used only physics, that is the solid state physics, which is used in the quantum physics also, which is used in the spectrum also, which is used in the mechanics also, so classical mechanics also. So many topic we have to use the free electrons model. So some of the scientists will be discovered of the free electron model, some various concept, but in concept we have to say that which the conductivity and thermal conductivity and electrical conductivity which works on the obeys of free electron theory of metals to use the Drude model. So we have to define in the case of main importantly Drude model to use the free electrons theory of a metal. So electron theory of metals will be introduced in the three stages. The first stage I am already say the Drude model and the classical free electron theory, quantum free electron theory, and band theory and zone theory. So you have to use the free electrons to different topics we have to study about it. But the mainly important discuss about the solid state physics which comes out of the solid state physics because of the semiconductor which is based on the only electrons and holes. So free electrons will be created in the cases of semiconductor because pentavalent and trivalent of the n type and p type semiconductor produced, when the cases the free electrons will be produced, or p-n junctions of the depletion regions to create the immobile ions. So we have to getting also same free electrons. So some of the introduce the free electrons theory, that is the classical free electrons theory. Drude and Lorentz developed this theory, that is 1900. According to this theory, the metals containing free electron obeys the laws of classical mechanics. I have told that already. The classical free electron theory which is discovered by the Drude and Lorentz in 1900 year. This theory which obeys the laws of the classical mechanics. For example, Ohm's law, that is the current is directly proportional to voltage. How to produce that and how to use the electrons in the cases of Ohm's law, or electrical conductivity or thermal conductivity, or how to free electron theory is the ratio of the pressure, and different varies obeys that in the cases of classical mechanics. So we have to free electrons theory which is used in the classical theory, And the second stage, the quantum free electron theory. The quantum mechanics of the free electron theory can be used. The scientist will be says that the scientist which name is Summerfield develops this theory during 1928. According to this theory, free electron obeys the quantum laws. The classical laws which obeys the Drude and Lorentz laws, and Summerfield which find out the which is free electrons, which is also used in the quantum theory also and quantum laws also. And the third one, the band theory or zone theory. Bloch stated the theory is 1928. According to this theory, the free electron move in a periodic field provided by lattice. This theory is also called band theory of solids. The concept of hole, origin of band gap, and effective mass of electrons are special feature of this theory or zone theory of metals. So Bloch, as a scientist, he also discovers the free electrons. That discover the free electrons which is used the periodic field or the concept of holes, origin of band gap, and effective mass of the electrons, and special features of the theory of zone theory of metals. So these electrons, which is theory how to develop the free electrons in three stages, that is stage 1 the classical, stage 2 the quantum, stage 3 the band theory. There are some different or variable scientists will discover the free electrons. The free electrons discover then the cases where it is works on this concept, so we have to use this. And the next one, classical free electron theory. Now Drude and Lorentz already discovers that the classical which does not obeys the laws. So we have some important points will be discussed about that the classical free electron theory. In an atom, electrons revolve around the nucleus. We have to know that already. The atoms of the electrons revolves around the nucleus, and every metallic substance is composed of such like atoms. And every metallic substance to compose the atoms, and which means the atoms which is the metallic compound which is revolving around the nucleus. The valence electrons of the atoms are free to move about the whole volume of metals like the molecules of a perfect gas in a container. In a big container, the container which the atoms will be covered, that is the valence electrons of the free electrons which is moved to the container. There is a molecule of a perfect gas which is produced the cases the atoms will be free, that is the valence electrons of the free atoms. The free electrons moves in random directions or collide with either positive ions fixed to the lattice or other free electrons. Because the free electrons will be random directions will be flowing, when the cases the current will flow through the aligned shape, the electrons will be flowing. The free electrons is always the positive ions. So in the case all collision are elastic, that there is no loss of energy. The free electrons all are elastic collision, but there is no loss of energy, because there is an inelastic collision will be produced, there is energy will be losses. But the elastic means aligned shapely, the directions will be flowing, so there is no loss of energy. The electron velocity in a metal obeys the laws of classical Maxwell-Boltzmann distributions. The main important of the free electron theory also obeys the Maxwell-Boltzmann distributions laws using the kinetic theory of the gases, because free electron theory to define Drude and Lorentz using the kinetic theory of the gases, kinetic theory of the gases to produce the classical Maxwell-Boltzmann distributions also. These are the classical of free electron theory. And some success of the classical free electron theory. First of all, I will say that some success will be there, some failure will be there. So introduce the free electron theory, classifications of the free electron theory to use the success and which obeys the laws, and some failures will be there. So what is the failures to discuss about the next classes. So what is the success of classical of free electron theory? So we have to say that what is the success of classical. First one, it varies the Ohm's law, and free electrons theory which obeys the main important is Ohm's law, that is current is directly proportional to the voltage. Because Ohm's law, the metallic conductor we have to taken, then the cases the electrons which flows through the positive direction opposite of the electric field, the current will flowing through it and the voltage will be developed across this using the free electron theory, so which is the success of the free electron theory, so which is obeys the Ohm's law. And second one, it explains the electrical and thermal conductivity of metals, because the classical theory of the using the kinetic theory of gases to find out, the scientists Drude and Lorentz to use the cases of free electron theory. Mainly important is electrical conductivity and thermal conductivity. So electrical conductivity is defined as the symbol rho, and the thermal conductivity which is defined as the sigma. So how to use and how to create of the thermal conductivity and electrical conductivity, now we have discussed about the next classes. And the next one, it derives Weidmann-French law, same as it is electrical conductivity and thermal conductivity of metals will be access or success of the or produce the cases of free electron theory, same using the Weidmann-French law, it is a ratio of the thermal conductivity and electrical conductivity, so which is also varied for the Weidmann-French law to success of the classical free electron theory. And it explains the optical properties of metals, it is used, or it explains the optical properties of the metals. Also we have to fiber optics, so optoelectronics, so we have to discuss about the light emitting diode, photodiode and solar cell to use the optical instrument. So we have to take or consider of the free electrons, so which is success of the classical free electron theory. These four of the success of the free electron theory is not, now we have many electron theory will be there. So discuss about the next classes will be what is a classical main important, how to define the expression of electrical conductivity of the free electron theory. Today we discuss about the only what is a free electron theory, how to define and how to introduce and where it comes to the unit, so we have discussed about in this classes. So mainly important solid state physics, which is the study of the physics to use the material in the amorphous and crystalline solid to using the electronics, holes, semiconductor and superconductivity, which is mainly used of the solid state physics. So in BSc 6M we have to introduce small unit, that is a free electron theory. The free electron theory we have to introduce the classification of free electron theory, expression for electrical and thermal conductivity and failure of the free electron theory, and what semiconductor, expression for the intrinsic semiconductor, Hall effect, Hall coefficient and applications, and superconductivity, introductions, destruction and advantages, and types and applications of the superconductivity. And now what is free electrons to use the semiconductor or solid state physics. Free electrons from outer shell of the metal atoms, and free electrons in solid state physics. So sample madam to behavior of valence electrons of the crystal structure. And Drude and Lorentz model we have discussed about the free electrons theory. There is a different various stages or various chapter we have discussed about the free electron theory, that is a classical, that is a quantum, that is a band, that is a zone. We have introduced the many units, so we have used the free electron theory and classical free electron theory and success of the classical free electron theory. And thank you. And next class we have discussed about the expression for the electrical conductivity. Thank you, one and all.